All right, today I'm going to talk about the properties of logs, which is 7.4. What we're looking at is we're looking at stuff like if I have the log with base 3 of 10 plus the log base 3 of 4, I can combine this to make it one log, but this only works when they have the same base. So because these both have the same base, my answer is going to be the log base 3 of 10 times 4. This will always be the case. When they're the same bases and you're adding them, you're going to multiply the two numbers together. Well, I'll do a different number this time. Log base 8 of 7 plus log base 8 of 2 is going to equal the log base 8 of 7 times 2. And we would combine that together and just make it 14, right? You can also go the other way. So if I have something like the log base 3 of 3x, okay, well, this is implied multiplication right here. So I can say this is really the log base 3 of 3 plus the log base 3 of x. Now, conceptually, why would I want to do that? Well, we know what the log base 3 of 3 is. Remember that anything, log base anything of that is going to be 1. So this is really 1 plus the log base 3 of x. So this is really why we're going to go kind of, why we developed this rule, is to be able to do stuff like this. This is going to be more simple to solve for. And we'll get to that later on. That's the basic rule though for addition, okay? Now if addition gave me multiplication, using your brain, what do you think subtraction is going to do? Oh, that's exactly right. It's going to be division. So if I have the log base 3 of 4 minus the log base 3 of 1, remember they have to be the same base, it's going to be the log base 3 of 4 divided by 1. Log base x of 2 minus log base x of 4 is going to equal the log base x of 2 over 4. So we would do this to make it into one number. That's why we would go from here to here, so that we can combine them together and make it a little bit easier to deal with. And conversely, we can go the other direction as well. So if I have the log base 7 of x over 4, I can make this into the log base 7 of x minus the log base 7 of 4. Okay? So that's really the main two rules for logarithms, is going from addition to multiplication and going from subtraction to division. Okay? Now the last rule is kind of the most important, because on most of our calculators we can't put something like this in the calculator. The only log that you're allowed to put in the calculator is the generic log, which is log base 10. So a lot of times we write stuff in math and there's something that's implied. Remember, when I write 3 by itself, there's an implied 1 right here. There's an implied exponent of 1. When I write the square root of 2 or 4 right here, there's an implied 2 right here. Okay? When I write just log with nothing there, no base, there's an implied 10. Okay? This is a new implied rule. So the base 10 is the implied base on logs. So if I tell you just the log of 3, we can put that in our calculator. And what this is saying is the log base 10 of 3, okay? I cannot put any other log in my calculator. I can't put this into my calculator. But what I can do is, this is equivalent to the log base whatever I want, which I'm going to always make it 10, of 7 over the log, same base, it has to be the same base that I did on top, of 3. So this is going to make it so I can put log of 7 in my calculator divided by log of 3 in my calculator. Okay? Now when you do this, just make sure you put it in parentheses, otherwise it'll probably give you an error. More advanced calculators, you can actually put this in. Most of the ones that we have, you cannot. All right? So I could change it to a different base. I probably wouldn't want to, but I could. Let's say I have something like this. And I could change it to be the log base 10 of 16 over the log base 10 of 4, and that would be easy to put into my calculator, and it would tell me 2. But I could technically also make it the log base 16 of 16 over the log base 16 of 4. The really important thing here is that these bases are the same. The bases have to be the same. Now, for most reasons, we're always going to go to base 10. There are very few cases, and I don't think we'll see any in Algebra 2 where you would go to anything besides base 10. Okay, so that's what we're looking at today. Now, these are the basic concepts, right? And of course, I'm going to give you harder problems, especially when we get to wave 1. But these are the basic concepts.